Oh, finally. Okay, so are we go live? Hello, are we go live?
点，嗯
Guys, can you hear me?
Yes, we can hear you.
Oh, great. So finally, let's begin.
There's a little bit problem with the internet and the technical issue here, and we can just begin the workshop now.
Okay, so I believe you can see my screen now, and oh, thank you for the long waiting. And hello, everyone. I'm Shelven Zhou from Phala Network, and actually, this is a recap of our Decoded presentation because Han and I we both gave these talks in China, in Hangzhou, in Decoded. But we think it's also a good idea to share it with our foreign community. So here is the broadcast, and I think in Friday night Han will also share our latest workshop. Okay, so today I will share my part, and my topic is to render your NFT from in contract, and yes, let's begin. Okay, so this is my bio, and okay, so in this slide I will generally introduce our Phala network and also about our fat contract, and especially I think we have some new thoughts on the fat contract about why it's so powerful and what it can do, what it should be used to do, and finally I will do some demos to show you what you can achieve in the next version of fat contract. Because actually I think in this year, in the past months, actually, we have worked very hard for the release of that contract on our mainnet, and now actually all the code has been merged, and I think just in the incoming 1 week or two, and we should just release the initial fat contract support on our mainnet. But actually, the initial release of fat contract will not go public. We will first use we will first enable our cooperation teams to use our mainnet fat contract, and then after we have finished the review of the whole week, something we call the level 2 tokenomic. It's about the tokenomic about how developers can pay and how to use fat contract, and after that part, we will really release the public clusters for anyone to deploy their contract to. But actually, before that, all the developers, you are still encouraged to use our testnet to test your contract. And after we enable that in the mainnet, so you can migrate it to the mainnet anytime. Okay, so the first is about Phala Network, and I think Phala Network is a Web3 computation protocol, and actually we are a permissionless computing cloud, which allow any people with the secure enclave hardwares to join our network and share computing powers. And by using the secure enclave also means that all the data privacy and the execution integrity of the contract are promised in our network. And also, we have we have shown that file network can be used with other storage solutions. For example, like the Amazon S3, like the R-Wave, like Crust. So actually, by combining the computation power of fat contract with the storage solution of the existing chains, actually you can have the full functional solution for your application. So okay, and this is a comparison between the Web 2 and the Web 3 cloud. So and the Web 2 cloud you can enjoy the privacy and the scalability in the Web2 cloud, because actually you can get as many as machines you need. But the problem here is that Web2 cloud, they are centralized, and also you need to trust that your service provider, they do not have some review on your data, and so this is the problem. But on the other hand, with the blockchain, actually, blockchain enable people to join the blockchain, and it's trustless. So everyone has the ability to verify that what's going on the chain. But the problem is all the data on the blockchain go public, and the current system design of the blockchain, actually, the computing power is not scalable. So you can see there is very expensive computation on the current blockchain. But to provide a Web3 cloud, actually, we need to combine the best part of the both to work. So that's what Phala does. That means we build a decentralized system, and we rely on trustless hardware, which is secure enclave, and we provide privacy. This means all the data, no matter all your transaction or your contract states, our nets are encrypted. And finally, we provide scalable computing power. That means you can all our workers, if, for example, you can deploy your contract to multiple workers in our network. And after you have done that, this means all these workers, they can handle the queries from the users in parallel. So unlike what happens on the Ethereum. Okay, so with the secure enclave hardware, so this means usually the secure enclave, they provide CPU level isolation. So this means your applications, even if the operating system itself is malicious, but you are able to directly in your application directly to utilize the security features inside the CPUs, and even if the malicious operating system cannot see what happens inside your applications or try to interfere with its execution. So this is the meaning of CPU level isolation. And also, all the memories are encrypted. So, and this encryption is done with specific chips on the inside the CPUs. So this means outside the CPU, no one can really know the real value in the memory. So by combining these two parts, it provides the confidentiality and the promise of execution integrity for us. Okay, so also I think Phala adopt full lifetime encryption during the first moment. For example, you have submit your transaction to the blockchain, it's encrypted, and during all the execution of your contract, all the contract states is which is stored on chain is also encrypted, and also all the traffic which users directly send to the contract itself is end-to-end encrypted. So this means all the things, all the privacy can be protected during all the lifetime of the data. Okay, so I think different blockchain, they adopt different solutions, and this comes with different limitations. For example, on the Ethereum, no matter how many workers there are, how many miners there are, actually from the user perspective, actually you can see that there is only one worker on the Ethereum. So this because, for example, when you submit your transaction on the blockchain, only the lucky miners which is selected has the ability to execute your transaction and get the result. But all the workers just do the duplication, verification, computation. And for the Polkadot, actually, Polkadot introduced the concept of parachains. So each parachains can do their own computation. So, and for example, now there is tens of parachains on Polkadot. So this means the Polkadot can provide tens of computing power compared with Ethereum. But on the Phala network, we try to, for example, all the workers, each workers in Phala network is independent. So this means every workers can do their own computation. So this means our computation power is linearly scalable with the number of all our secure workers in our network. Okay, so next is about our fat contract. So first, front side and the fat contract is an innovative programming model for Web3 cloud. So why we say so is because I think the most significant advantage of fat contract is that you can it allows you to do off-chain computation in fat contract. But before we go that depth, and I think first fat contract itself is written with Rust, and more specifically, you are writing your smart contract with the Inc language from Parity, and the Inc actually is annotated Rust code. So, and after the compilation, your contract will be compiled into the Wasm bytecode, and you can upload this to our blockchain, and this will be finally deployed to one of our secure workers for the off-chain execution. Okay, so this is the overview of one node, for example, one worker in our network. You can see that the worker is consists of three parts. So the first is the substrate node, and I think all the parachains share this part because you need substrate node to form the blockchain. But your contract will be executed in the off-chain secure enclave here. So this means your back contract is all its states is encrypted by hardwares, and so this is the off-chain part we have just said. And between these two parts, there is the bridge called the ferry, and the job of ferry is to first it continuously sync all the blocks from the blockchain to the secure enclave for execution, and also to let the secure enclave to know about the current latest state on the blockchain. And also it will sync back, for example, your execution results, your update of your contract state back to the blockchain. Also, by executing the contract inside the off-chain secure enclave, this means we allow users to directly interact with our workers instead of just interact with the chain. So this means also, for example, just like a traditional Ethereum smart contract, our users, you can still, for example, send transaction to the blockchain to interact with the contract. So this part we call is the on-chain command, and this part is the on-chain execution, just like traditional smart contract. But on the other hand, for example, since our contract is deployed to the off-chain workers, they are just like servers. So this means the users, they can directly interact with the servers without touching the blockchain. So this is what we call the off-chain computation part. So, and this provides the real experience of the client server interaction, just like normal cloud computing cloud. Yep, and when you're using the off-chain computation, actually, it's bring you many benefits compared with the traditional on-chain execution. For example, when you are interact with our off-chain workers, there is no latency because such interaction did not involve the blockchain, so you do not need to wait for the block production. And also, actually, as I have said, actually, all the workers, they can serve our users in parallel. So this means actually one contract, if you deploy it to all our workers in the blockchain, so this means one contract, it is utilizing all the computing power of the Phala blockchain. And also our off-chain workers, they are secure workers. So your data privacy is promised. And finally, our secure workers, they can safely delegate the HTTP request for your contract. So this enables many interesting applications. Okay, so I think we can dig a little deep into how the legacy, the traditional smart contract works. So actually, this is what happens inside the Ethereum every day. For example, in Ethereum, all the users, you need to submit your transaction. And from the blockchain part, all the miners, they will continuously collect all the transactions. And after certain interval, like in Ethereum, I think the time is 6 seconds. After 6-second interval, the lucky workers will be picked to do the block production. And in this process, it will pack all these transactions into a block. And also it will execute all the transaction. And this is where the contract execution happens. And after that, it will append the block to the blockchain, and then it will do such things again: transaction collection, block production, and contract execution. But the problem here is twofold, I think. So the first is that you can see the wait time here. So actually, the real execution time for the contract is very limited compared with the long transaction collection and the block production interval. And the second is that your execution is broken into pieces. So this means, for example, at this time, maybe the worker A is lucky enough to be chosen to execute your contract, but in the next block, maybe worker B is chosen to do the execution. So this means, for example, something like the long-lived network connection. For example, you need to download a very large file, and it can take a long time. Such kind of long-lived network connection and some asynchronized request is impossible in the current smart contract. But in our design, actually, the story is a little different. We can see here, because we detached the on-chain part and the off-chain part. So here we can see that the contract execution, it continuously execute there. So, and the only thing happens during the block production here is that the contract will fetch the transaction and the block from the blockchain and update its state and write back the new state to the blockchain. So this is the only thing happens. But on the other hand, for example, your contract can continuously serve all the queries from the users anytime. And in this graph, I just update something called the side VM. And I think the side VM, this is the most important feature we will introduce in the next version of that contract. And I think side VM further released the limitation on the smart contract, because even if we have moved the smart contract off-chain due to the limitation of the contract model itself, something is still not permitted in the contract. For example, you are not allowed to use the STD library in the contract. And also, although our contract can do some HTTP requests, for example, but it's not allowed to listen to some port and to serve as a HTTP server to the users. But all these problems can be solved with the side VM, because side VM is like the demo process of the contract. So it's this means it do not have any limitations that's for the smart contract. So, for example, the current side VM actually is already supported in our testnet, and the current side VM in it, you are allowed to compile the target to Watson, but with STD support. And another things we try to support inside the VM is to allow it to execute any Docker images. And just as I will show later, it's still a demo, but we will show that it's very easy to slightly modify your Docker image and get it running inside the VM. And I think actually we can do more inside VM. For example, many people, they always ask me, maybe, can I write my program with Python with Node.js, because these programming language are much easier to use. But previously, the answer is no, because you cannot do that in the traditional contract. But with side VM, actually, it's possible to do that, because we can run the Node.js interpreter or Python interpreter inside the side VM. So this means your Python script or Node.js script can just execute it, can just get executed in the side VM. So you can use your contract to manage and interact with them. So the question is that when shall we use the off-chain computation? I think there can be many very simple principles for you to determine that, yes, in this case, I should use off-chain computation instead of the traditional smart contract. So the first is if you need to use some off-chain data, you should use off-chain computation. And I think the most typical scenario here is the Oracle, because the job of Oracle is to introduce off-chain data to on-chain. But so that's why many people try to just implement the Oracle with that contract. But actually, it can do more. Okay, So, but the second principle is that, for example, when you think that your contract need to process some high frequency requests, and for example, in the traditional smart contract, you need to wait because such job is impossible. But in our case, it's possible. And the third principle is that when you think that in your situation that gas fee matters, because I think even very simple computation on the Ethereum can be very expensive, and the other blockchain, even if they have lower such price, I would say, but it can be still very expensive. For example, you try to do some very complex computation, like I would say machine learning, and but things in the off-chain computation, actually, we have adopted a totally different tokenomic. So, which means you do not pay for each instruction anymore. So it's not gas fee based. So instead, you just rent our workers. And during this time, when you rented these workers, actually you can do any much computation you want in it. So the price still keep the same. So this means when you think that your computation is too expensive to be done on the Ethereum, then maybe consider doing that on Phala. Okay, I think also the features of fat contract can enable many interesting applications, like decentralized exchange, like the NFT image rendering, which I will demo later. And actually, some developers in our community, he successfully get the DNN running, the AI model running in our workers. So it's also very interesting. And like the metaverse backend, actually, I think it can be a very good support for the Phala world. And also, just like Oracle and Bot, if you try to implement that, just use fat contract. Okay, so next let's really do some. Let's really see some real fat contract here. So okay, so this is our previous workshop, I would say. So the idea of this program is to use fat contract as the root of trust to attestate some off-chain data. So let's see the progress. First, our target is to prove to others that, for example, these users, he owned some GitHub accounts here. And to achieve that, actually, he can file a attestation request to our fat contract, and the contract will generate some magic for him and ask him to post a GitHub gist with his account. And after the user has done that, our contract will send an HTTP request to the GitHub to verify that the users he really send this content, so we can know that he really owned this account. And after that, instead of store such, for example, the mapping between the user's account to his GitHub account on chain, I think another good solution here is that we can give him a report. So this report is signed by the secret key of our fat contract, so no other entities have the ability to fake this. So this report will prove that this user really owns this GitHub account. And in the following time, for example, if anyone tries to verify that, he can just get the pub key of our contract from our blockchain and verify this report. And why will we do so? Why wouldn't just store this information on blockchain? Because if we try to do that, actually it will fall back to the previous on-chain execution model. So this means you need to pay gas fee for that, and these things can get very slow if you try to store the things on-chain. But if by using this attestation pattern, actually all these things happens off-chain, because you can see there is no request in this process involve the on-chain part, except that you need to read the pub key of our contract on-chain. So all this process is called the off-chain attestation process. So, And this means you can get the report immediately, and also all the other users, they can verify your report immediately and anytime. And I just give some example code here to show you how to send the HTTP request in our contract. And I think it's very easy to use, because actually to send the HTTP GET request, you just use the HTTP GET micro. And also for the post, just similar, use the HTTP post micro. So it's very easy to use, just one line invocation and you can get the data. And I think the HTTP request can be used to read something like the token price, some tweeters, GitHub repos, and other file from Amazon S3 or Aave. So this is what's called the off-chain data. You can just read them and process them. And also the HTTP request can be used to do something. For example, you can use it to send the email, to send a Twitter you want, and you can use it to build a Telegram Discord bot, so it can interact with others, because this can still be achieved with HTTP request. And this allows you to use any services which has HTTP APIs. Sorry. Also, since we encourage our developers to do most their job off-chain, because of all these advantages we have, I have shown. I think a local cache is also very important for our users, because you cannot store all your contract state on-chain, because it's expensive and slow. So that's why we provide the local cache for our users. So it's also very easy to use. It's just a very simple key value store here. And the most important feature of local cache is that it's free and it's fast. So you don't need to wait, just store it and it will be there. But the limitation here is that first, the local cache is not shared across multiple workers. For example, if you deploy your contract to multiple workers, each workers can have their own local cache. But for example, if you try to store the value inside the contract states, such storage will be shared across all the workers. So this is the difference. And another important features here is that the local cache is volatile. So this means if one of your worker is down, or you choose to deploy a contract to another workers in our network, that means the previous local cache will get lost. So these things, the local cache is should only be used to store some not that important data. Okay, so the next is the demonstration of the our rendering example here. Okay, so before I really show that, let me explain what happens. So the first thing is that it's about to show you that we can render the NFT image inside our workers. And to do so, actually, the artist, they should first finish their model and upload it somewhere, like for example, Aave or S3. And then he should input the handler to this file to our contract, so our contract can read this model. And then it will decrypt this model and do the rendering job in our workers, and it will upload the results and also encrypt it and to the storage for users to download. And finally, the users can get his results. So here we just input the handler to this file, and it should take a little time for the workers to read this file and begin the real rendering process. So here, this is the log interface of our workers, and you can see that the current the rendering is happening here. Okay, and after that, it will give you the link to the final results, the rendered image here, so the users can use it to download. Okay, so finally you can get the image here. So actually, in this case, first we show that we can run the Docker image in our workers, and with very little, almost no modification here. And another important usage of our contract here is we call it the file NFT, because since your data privacy is promised in our contract, actually it's possible to make your file an NFT in Phala network. So let's see what happens. For example, the users, he can first upload a file to our contract instead of directly to the storage. And after that, our contract will generate an encryption key for this file, and also this key will be used to encrypt this file. And also our contract will delegate the upload for the users, so the encrypted file will be uploaded to the storage, and the link will be recorded here. So the pair of the key and the link, actually, this is one file NFT, we will say, because by owning this file NFT, actually, you are the only one in this world which has the permission to get this file and decrypt it and see its real content. Okay, so also the users, after the upload, he can ask our file to do ask our contract to do the rendering for him. And in this case, our contract will do first it will do the access control to ensure that the users are really the owner of this file NFT, and it will download the file for the users, decrypt it, and send it to our rendering service. And after the rendering is finished, the result will still get encrypted and uploaded to the storage. Finally, only the users can ask our contract to decrypt and get the final result for him. So this we can see with this so-called file NFT contract, actually, you can just turn any untrusted storage service into a trusted one, because only the encrypted file are stored to this storage. So no privacy leakage anymore. Okay, so sorry, I think this link is a little outdated. So the latest link, you can search for the Oracle workshop in Phala network, and it will give you the latest workshop we gave. And also Han will demonstrate that up to date. Okay, thank you. So if you have any questions, actually, you can post it here. Okay, no questions? Oh, so let me share the latest workshop for you. And I really recommend you to do that, because if you have finished that, you can get 2 POP. So there is a beginner challenge there, and also an advanced challenge there. And with that, you can first you can experience our new contract UI, which is very easy to use from my part. And also you will learn to deploy and write your own oracles in just 15 minutes. And also, I think the great part is that we have a contract to judge whether your contract is qualified. So this is very cool. And if you have passed both the challenge, you will get each 1 POP for each challenge there. So give it a try if you are interested. Okay, so seems no question here, and thank you guys to be here, and sorry for long waiting. And I think just 2 days later, still here, Han will will help you go through the whole workshop, and let's see what we can do with the latest back contract. So, okay, thank you to be here. and bye-bye.